Welcome back for Explain 3, Modeling Exponential Growth Functions. So here we're given an example 3, how to apply what we learned about exponential functions to real-world problems. So here's a gentleman, Tony, purchased a rare guitar in 2000, not for $2,000, but in the year 2000, for about this much money. So that's how much he bought it for. Experts estimate that the value will increase by 14%. Now this is an estimate, but we usually want things to increase in value. So he kind of probably bought this as an investment and hopefully that the guitar will be worth more and he could sell it for more later on. And that's going to be 14% per year. It says use a graph to find the number of years it will take for the value of the guitar to be 60,000. So the first thing we're going to do is we're going to write a function to model the growth value of this guitar. I'm going to identify my initial value, which he bought for 12,000, as my A value. And then our rate, or R, is going to be my percent. Now I do want to change that rate of 14% into a decimal. And the way we do that is we divide by 100. To figure out what our R value is as a decimal. So take some time and divide that out. That would be about 0.14. So we're going to plug in some values. So as a function of time, over time, that guitar that was worth $12,000 is actually going to go up in value by about 14% or 0.14 to the t power. We can then simplify this down to 12,000, and 1 plus 0.14 would be what? 1.14. We are going to use, it does say for us to graph using a graphing calculator, but if you don't have one available, we can definitely use our favorite online graphing calculator known as Desmos.com. Okay, so I'm going to do that right now. So I'm going to open up a web browser side by side so you can see how I input these values into our graphing calculator. So the first thing I'm going to write in, instead of f of t, I'm going to actually write the letter y equals $12,000. Okay. I am then going to write in, so you can see this on screen. This does have a keyboard. Just so you know, so we can show the keyboard or hide it, but I'm going to leave it up as is so that we can find our parentheses key, 1.14, close the parentheses. Now I do need to put in an exponent, so I'm going to use a to the b power, which will give me an exponent, and I'll write in x. And then I'll write in, since he wants to know for $60,000, I'm going to write second value of y equals about $60,000. And as you can see here, you're like, wait, Mrs. A, I graphed the same thing and nothing appears. So what I'm going to do, so you can see, I'm going to zoom out. And I'm going to zoom out by a lot. Ooh, I see my first graph. I'm going to zoom out. You're like, how long do I have to zoom out for? Well, we want $60,000. So I can see I got up to 20,000, 40,000. Oh, there it is. There seems to be. Now mine is a touch screen, so I can zoom in using, and I can see actually by just kind of clicking on where I think that they're going to be at. Ooh, it shows that my original graph for the guitar and the 60,000 that is desired actually crosses at 12.283. comma 60,000. So after about 12 and some change years, that guitar is going to be worth about 60,000. So just so that I can kind of keep that going here. So let's go ahead and write that in on our paper. So just as we saw on our graphing calculator, we saw that after about 60, the guitar will be worth about $60,000 in approximately 12.283 years, which would be, since this was bought in 2000, that would be maybe 2012 to 2013, Tony could sell this guitar for about $60,000. All right, let's go on to explain B. So here they give us a different, Tony again has bought another, at the same time Tony bought the $12,000 guitar, he also considered buying another rare guitar for $15,000. The experts estimated that this guitar would be worth 9%. Okay, determine after how many years the two guitars will be worth the same amount. Okay, so let's say he hypothetically bought two guitars. So this guitar that he's considering buying is $15,000. So he would buy it initially for $15,000. And he would increase in value a rate of 9%. So a rate of 9%. We're going to change that again into a decimal by dividing by 100. So if you haven't already done that, try that out. And that would be about 0.09. Okay, let's simplify our equation. That would be about 15,000 and 1 plus 0.09. 1.09. Use a graphing calculator to graph the two functions. So again, we're going to use our favorite Desmos to see at what point these two guitars might be the same. Alright, again we're going to use our Desmos, so I'm going to use the same window that we just opened up for part A. 12,000 parentheses 1.14 to the x power. I'm going to type in our new equation of 15,000, and that would be 1.09 to the x power. So you can see here it does cross. Now if your screen does not look like mine, we could zoom in or zoom out. I might suggest here, because when we zoom in or zoom out, it may make the values on our x value a little bit larger. Since we're talking about years, we want this to be as wide as possible. And the way I'm doing this is I'm putting, with my touchscreen, both fingers to kind of stretch this out. And then I can always include more values by kind of, again, vertically placing my fingers on the y-axis and kind of either moving in or moving out. As you can see here, they do cross, so I'm going to go ahead and press our key. So after about 4.9 years, they're going to both be worth about $23,000. So on here, I'm going to go ahead and write that in. So after about 4.9, really 5 years, they'll be worth about that much. So let's go ahead and write that in. So just as it said there, after about 4.9 years, or 5 years really, because that's what it really boils down to, both would be about 23,000 and some change. Okay, so after either about 4.9 years or about 5 years. Just like it says in your packet, go ahead and stop here and try and do the problem for Explain 3, and we'll be back with the next section.